Well, good day, everybody. On behalf of FPSA, thank you so much for joining today's webinar. My name is Christine Radke. I'm the Director of Networks and Special Projects here at FPSA. Today's webinar is brought to you by the Technology Network. And before I introduce today's moderator, I just wanted to go through a couple of housekeeping items real quickly. At any time, you can enter questions through the questions pane, and we have Brent Wassel from Cybertroll. He will be monitoring the questions that come in, so enter them at any time. Also, after the webinar, you're going to receive an email which will have a link to the recording of the webinar as well as a certificate of attendance. Now, I know that some of your sites, you might have more than one person there. If you need another certificate of attendance, just send me an email and I'll send something to you. Also, in that email will be a link for a survey. Please, if you can, please answer it. There's only 2 questions, but your feedback is so important to us so that we can ensure that we continue to provide meaningful and good quality programming for our members, and as well as the topics that you want to hear and need. So now I'm going to pass this to our moderator, Matt Hartman. Matt is the chair of our technology network, and he is a senior automation sales engineer at Blendtec. So, Matt?
Well, thank you, Christine. Welcome, everybody, to the show. We have Sugar Creek Manufacturing with us today, and we're going to be having a really in-depth conversation of how they've actually implemented the industrial Internet of Things. It's a pretty deep topic. There's a lot of hype around it. But I was excited to have them on the call specifically so we could find out what they've done and how they've been successful at doing it. We have a couple of things I need to talk about, a couple of announcements. So I wanted to let everybody know that on January 23rd, we're going to be having another webinar on high pressure processing technology with Carol Tonnell Sampson. She's a PhD. And we're going to have an exciting conversation on high pressure pasteurization and some of the things she's been doing in that world. Then also, please keep in mind, everybody get registered for the annual conference in Carlsbad on March 4th through the 6th. So what we're going to do is go ahead and get started with Dan. So I'm going to do some introductions here. We have Dan Stoft, who's the Director of Operational Technology. After spending 21 years in the automotive industry, Dan joined Sugar Creek, a privately held food manufacturing company, 7 years ago. In his current role, Dan leads the OT side of the corporate continuous improvement team, which is comprised of engineering, IT, maintenance, and operations personnel. Dan's group is responsible for bringing relevant and actionable data from the plant floor to managers, supervisors, and operators in a format that enables effective decision-making and problem-solving. We also have Craig Langhals, who's Director of Continuous Improvement with us from Sugar Creek. Craig has 28 years of experience in food manufacturing industry, spending the past 18 years concentrating time on learning, perfecting, and coaching others in continuous improvement and process improvement. He's also concentrated on developing and utilizing tools that help to simplify the delivery of manufactured foods. Craig has been with Sugar Creek for 8 years, including roles as plant manager, HR manager, and business unit manager at the company's high-speed bacon slicing facility in Dayton, Ohio. So, gentlemen, are you with us?
Yes, sir. Yes, we are.
Wonderful. So, my first question I'd like to ask you guys is, could you help the viewers on the screen here, just help us understand what got you guys going down the road of IIoT, the industrial Internet of Things?
So, as a backstory, our company is privately held. It's been around since 1965. When our current owner purchased the company from his dad in 1982, we were doing about $12 million in sales. This year, we're on track to do about $800 million in sales. So rapid growth. The problem was, both of us joined the company about 7 years ago when John recognized the need for more horsepower. They were kind of running a $400 million company like a $12 million company. So there wasn't a whole lot of automation. Everything was manual. And John brought in a lot of talent from outside. Like you said, I came from automotive, and automotive is very, very data driven. And he basically wanted to get Sugar Creek up to speed with the latest technologies to enable the manufacturing process to be optimized and go fast. So that kind of answer your question from the start point?
Yeah. Was there a particular problem that you were trying to solve? Whenever John brought you on board, did he say, hey, Dan, go after this target, go after this, solve this problem?
I'll defer to Craig on that one. No, but the thing was, we were flying in the rearview mirror. There was nothing that could tell us how we were doing at any given time until the next day or sometimes the next week when the financials came out and the sales and shipping reports came out. So the immediate need was to make, what's going on the plant floor visible and actionable in real time. So, Craig's background, he came from some very large manufacturing, food manufacturing companies that were doing this. I came from, automotive, which was doing this. So, what Sugar Creek was kind of doing to get their data, it was a lot of clipboard monitoring, if there was monitoring at all. And obviously, if the data is on a clipboard, until that clipboard goes somewhere where people can view the data, it's in one place. In some places they had whiteboards, on the line where they could jot down what was going on. But again, that relied on somebody to actually jot it down and somebody else to actually consume it. When we first started, we were calculating downtime based on what we made versus what our standard was for that product, and the delta in produce versus what the BOM said that was our estimate of what the downtime was, but we didn't have causes, right? Unless there was something big that somebody reported. So the big jump came when we decided to do a machine data collection system and connect everything to it and make dashboards and reports and automate what was previously manual.
So whenever you say, I came from automotive as well as Dan. We've talked about this quite a bit. That we've seen a lot of things in automotive, and in the past, in the 90s, I remember writing lots of PLC code that to create tons of data, block starved, uptime, downtime, all sorts of things like that. And what I saw happen was nobody really cared. It never got used. Could you what did you run into that at all?
This is Craig speaking, but that's when I saw what Dan was doing, and he was dying for somebody to utilize the tools he was developing. And as soon as I got a whiff of it, as a manager, I've been craving this information my entire career. So as soon as I got a whiff of it, I was all over him. So that was 4 years ago, and I haven't stopped asking him to do stuff since. So just having the data and being able to present it in digestible bites and feeding it to the masses is valuable.
So could you tell us a little bit about some of your successes as you started collecting the data? What did you find?
So I'll give you the end result first, and then we'll go through the process that got it.
Sure.
Maybe, if it'll let me. So this is OEE on one line, a month.
Hey, Dan, before you go, what does OEE stand for the audience?
Overall equipment effectiveness. So it takes into account, there are 3 different metrics. So one is availability, which is uptime versus downtime. One is performance, which is rate loss. And one is a quality component, which is quality loss. So if you're running at 90% uptime, at 90% performance with 90% of quality, you multiply those together, and that is what your OEE is. So for us, everything is downtime. It's all opportunity. So we do not differentiate between planned and unplanned downtime. So our breaks and lunches are considered opportunity, right? We have the opportunity to work through them if we staff correctly. So if we run perfectly and we take breaks and lunches, the maximum we could ever have is right around 78%, I think. This particular, the green line is the line you're never going to hit. That's 100, but you gotta shoot for something. This particular plant is representative of most of our plants. We've put this in all of our plants now. We've got all of our finished goods lines are connected, and the majority of our pre-processing is connected also. We report out on OEE weekly. Our target is not a specific number, it is actually just improvement. We want every week to be higher than the prior 4 weeks. So this particular plant, we doubled our productivity in 6 months. It's not too bad, right?
So let make sure you say that again. You doubled this one line or the overall plant whenever you say you doubled it?
This is a plant with 6 manufacturing lines in it. This is the overall for the plant.
And so I think that's a pretty staggering number. I mean, that's unheard of. And I'm kind of taken back whenever I see that you doubled production in 6 months that had 6 lines running in one plant.
Correct. And this is our best, but our worst performer in the first 6 months, we got a 40% improvement, which still isn't too shabby. And a big part of this really had nothing to do with the data. It was more Craig's, the way that we changed the way that we measured our performance. You know, in the past, and Craig's going to go into this a little bit later, but in the past we were set to BOM standards, and we recalibrated and actually went to a theoretical maximum output for a given product on a given line. So for instance, this particular plant is 6 microwave bacon lines. They're all pretty much identical. We actually figured out how many watts of power you could theoretically cook a pound of bacon in, and for every SKU, based on the output of a given microwave line, we figured out what the maximum, the theoretical maximum rate is, and then that was our target. And that was significantly higher than our BOM rates.
Whenever you say BOM rates, I'm not familiar with how you're using that.
Okay, let me flip to this. I'm going to flip to a different screen real quick. Hold on. All right. Craig?
Right. Our BOM rate is a bill of materials. So when you sell something to a customer, you negotiate, you get here's the material that goes into it, here's the throughput that we think we can achieve, and here's the labor involved. So you have a BOM standard to break even. So what we traditionally have done is break even. As a plant manager, once you get there, you're happy. Hey, I'm making money. I'm breaking even. I'm making money. I'm good. So we wanted to look at it a little different, utilizing zero-based analysis, which is 100% of the day. So you never stop trying to achieve more just because you are making money to a bomb standard. You're always trying to get to 100%, no matter what line you're on. What we historically had done, once we get to bomb standard and coast, plant managers will negotiate that for the next year, and then it's a cycle that never stops. So utilizing zero-based analysis, you never stop trying to improve. And you know where all your opportunity is.
So by using the zero-based analysis for the bomb standard, if you look at this chart, this is 3 lines hypothetically, right? And the bomb standards are 30, 50, and 80, and those are based on, historical run data. So in this case, line A was over their bomb standard, line C was under their bomb standard, but obviously line C ran better than line A. In the old Sugar Creek, everybody would be running the line C because it didn't hit its standard, even though it almost doubled what line A was doing. And line A, whoever ran that line would be getting a pat on the back because they hit their standards. What we look at is the opportunity and ignore the standards. And the opportunity is given based on a computed value for any given product on any given line for how much can that line possibly make of that given product. So that's the opportunity when we went after right out of the gate. And that's why when you see, and again, when you see this, you see a real rapid rise and then it kind of tails off. Well, we hit all the low-hanging fruit on this given line, right? So now we've still got 30% of opportunity, but to get that is going to require us to do something different. So maybe automate, upsize. It's something that's going to require something else.
So are you saying what I'm seeing here then? So you doubled your plant capacity, or you doubled the opportunities you got, or you doubled it, right? You were at a certain level, you're at A, you doubled that, and now what you have left is just that remaining opportunity against your theoretical maximum OEE.
Correct.
Okay. That's pretty amazing, though. I mean, if you think about that, that's really amazing what you've been able to do with the whole concept of the industrial Internet of Things, of just collecting that data. You're able to double capacity and just really focus in on that first low-hanging fruit that nobody even knows about.
Yeah, a lot of everybody thought when we got into this that all the reasons for all our losses were downtime. In the majority of the lines, I could probably say all the lines, the majority of our losses were actually in rate loss. We didn't know, we ran the product at the rate to hit the bomb standard, not knowing how fast we could run the product. Does that make sense?
Could you say that again?
We historically ran the product at a rate that would allow us to hit our bomb standard, not at the maximum rate we could run the product.
Got it. Right.
So some of these, Craig's got a great example about a packaging machine in our plant in Indiana.
Usually this works in a couple of different steps, but the first step is how fast can this machine run? And they told me 10 cycles per minute. And then I asked, well, why are you only running 4 cycles per minute? And they said, well, we have 4 people on the line hand feeding patties into this certain machine, and that's as fast as they can go. But when you meet with the people and you tell them, hey, our goal is to run this line 10 cycles per minute, and what do you need that will help you to achieve that? Just by communicating that there is a desire to run at a higher rate, you get usually a shot in the arm of 20%.
Like it's a step function.
Yep.
Like bam.
Oh, I didn't know I was supposed to. And you break it down for the people, and you vertically align it so that they know, oh, my job is to take X amount of patties, X amount of times each minute to be successful. and you just got to communicate it to them over and over and over again. It's a daily review. But that's usually the first step, and you get the big jump. And then you start redesigning lines around how to gain more improvement, and ultimately get into automation and other stuff.
So let's go back though. Whenever on some of your comparisons though, like you had lines 1 through 6, were they in the plant that you have up here right now, were all 1 through 6 behaving the same way and getting the same OEE levels, or was like line 6 outperforming line 2?
Yeah, so when we initially went into this, the question is, where do you start? How do you eat the elephant? This overview is a dashboard that we made for plant in Dayton, Ohio, and those are a set of 6 microwave slicing lines. So you've got a slicer, you've got a microwave, and then you've got packaging at the end of it. So the first thing we did is built the dashboards, and then we went after our biggest underperforming line, which in this case was line 5, which was making a product for a very large customer that we basically couldn't make enough of. So we went in and we put a whole process into fixing that line. So we knew that once we got one line, we got a process in the data for one line, then it's just rinse, repeat 5 more times and you get all 6 lines. And then, oh, by the way, we got another plant in Kansas that also has 6 lines. So you just plug it into that. So by putting a process in place for one line, we basically at the end of the day got 12. So what that process looks like is this is a busy chart. We're actually in the midst of flipping these over to high performance HMI style. But for each one of these lines, we've got the PLCs for the slicers, microwaves, and packaging machines all plugged into ignition. So we know when the lines stop. But we don't necessarily know why the lines stop. So what we do is we've got people on the floor with chrome pads that are actually coding downtime events. So in this particular case, it says it's stopped for half an hour, and the operator will come over and pick what caused it to stop. Just because the microwave stopped doesn't mean the microwave was the root cause of the stop, right? They might have stopped the microwave because the packaging machine went down. They might have stopped it because the slicer went down. So we have a predetermined set of downtime codes, in this case, change of blade, that the operator on the floor codes all the downtime events in. Once we have the real data, now you've got the opportunity to slice and dice the data, and our favorite methodology to do that is Pareto's. So in this case, you've got the microwave, you've got a CFS, which is a packaging machine, you've got a papertizer, which is the machine that puts individual slices of paper on that wax paper, and you've got a line, you got a slicer. So obviously the microwave is the biggest issue in this particular issue, and you can drill into what the issues are. So we've got 28 minutes of downtime that on this particular day wasn't coded for whatever reason. That's a management issue. And a lot of the times that's really short stops that actually roll up to more time. We've had issues with arch, hit a cavity fire. So it lets you drill in and really see what's going on. But when you have the data, that doesn't really give you much. You need business processes, and that's really where Craig came in.
Before we go down this road, I have a question that kind of made me wonder whenever you're showing the screen of all 6 lines and then how you deployed it. Did you guys run into any headwinds as you're like on line 6 trying to improve things? What sort of problems did you run into, and how did you resolve it?
Oh, you, Craig.
Well, employee engagement, manager engagement is always the main issue. Just having the data and having managers stare at it isn't really doing anything. So you really have to drive a performance system at the same time. What we implemented was a daily, we call it a review and response, daily direction setting meeting to review this data and then just beat the managers every day into submission. And this is how you're going to run your company. So we have a cadence to that meeting. We review the same thing every day, every line, every plant, and that's the goal, is just to get everybody doing the same thing every day at the same time, the same way, to make success repeatable. So the main thing that we see in the beginning is resistance to change, resistance to a new way of doing things.
In some cases, the people thought we were going to come in and beat them about the face and neck with the data. Really, we didn't come in to point fingers at anybody and blame anybody. It was just we wanted to figure out what was really going on and how to fix it and engage all the employees to do that. You know, in some cases, just doing the daily direction setting meeting, you know, you've got, you know, quality there, ops there, you've got, you know, the production lead, you've got the maintenance guys. In some cases, you just find out that production's having a problem that maintenance doesn't know about, that maintenance can fix like fast. You know, just getting people talking on a daily basis and being focused on what's truly going on is the key.
Hey, Matt, we had a question on the data collection.
Go ahead.
A question came in on the actual data collection. So we're talking about gathering a lot of data from a lot of different sources. And the question specifically is on, as far as the data collection goes, did you use the OEM data collection devices that may have been supplied by the manufacturers, or did they use third-party IoT integrator to capture the data?
Or
That's a great
C,
question.
none of the above. None of the above. We created this entire SCADA system, an MES system in-house, and it's all based on ignition by inductive automation, and we use the MES modules from Stephasoft, but we didn't use an integrator, we didn't use any of the OEM solutions. We built it all in-house.
That's impressive to bring that sort of expertise and keep that expertise all in your building. That's very impressive. So if we go back to you talked about the culture. One thing I was pretty encouraged by, which you said, I think people fear is that whenever you start going down this road, collecting the data, people start to fear how the data is going to be weaponized against you. And it sounds like you were able to navigate those waters pretty well. Was there any lessons learned as you went down that waters of just to keep that engagement with the people, that you're not trying to weaponize it? Is there any lessons learned there?
Well, usually success breeds success. So our goal was to engage the team, engage the managers. As we went into the plants, these dashboards weren't fully developed. Dan's team would develop a dashboard, and then I would go in as the liaison to basically interviewing and working with the management group. In Dayton, for instance, I spent 8 months, and the management team there were the ones that would ask the questions, and we would develop the tools to give them the answers. And as you do that, it's really, you know, engage the team more and show them that it's successful. That just kickstarts everything. Once they see a little bit of success and they were the reason, they were part of it, then it just breeds more questions, more success.
Yeah, that's the key to having, when you start it, go after a pain point and eliminate the pain point. So in this case, we went after, the one line that was grossly underperforming, and we just about turned it into the best line. And then all the other line leads wanted us to do it to them because now they were getting smoked by their coworkers, and everybody wants to be the best. So we turned it into a platform that enabled them to better do their jobs, and we responded to what they wanted out of it. We started with what we thought they needed, but it turned into what they told us they needed. They got to start somewhere, right? So we started, and it just morphed, kind of like a living, breathing organism.
Yeah. Yeah, we didn't know what it was going to look like when we started.
Well, and I think, as I like what you said, you got to start somewhere, and you got to just start iterating it, and you just have to pick a problem and see how you solve it. And I'm just, that's really encouraging how, you said something earlier, how do you eat an elephant? It's one bite at a time. And you clearly have done that, and success after success. So my question I'm going to take to Dan, because I know a lot of, on some of these webinars we've done in the past, people are hungry for technology and details of how you did it. Obviously, you don't want to reveal any IP, but could you go into a little bit, maybe some of the tech that you used and how you're able to get successes with that tech?
Yeah, sure. So the overall project is actually quite large. We're connected to about 190 devices, monitoring around 30,000 data points. Some of those are not production related, so we do our refrigeration systems, wastewater treatment systems. We monitor utilities. We do it all through, the one platform and the one project. We're actually running all 6 plants through a single ignition gateway, which Inductive says there's no way in hell we'd be able to do, but we're doing. So they were wrong. You know what I mean? They wanted to sell more gateways, which we didn't need, but we're actually going to a distributed model now. We're in the middle of an upgrade going to the new version of Ignition and the new version of MES. But some of the equipment was plug and play. Ignition works really well with Rockwell products, and we're primarily Rockwell. Ignition will talk to any PLC, so the majority of our equipment was already Ethernet capable and was either probably 90% Rockwell, got a couple Siemenses laying out there, and then a couple oddball proprietary control systems out there. So the Rockwell was easy. When we got into positions where we wanted to, for instance, water monitoring is huge for food plants because you're doing sanitation, you want to know where the water's going. So for those, we actually put Ethernet capable water meters. They're actually non-contact water meters that go around the pipe, and they speak via Ethernet I/O. And we created what we call data concentrators, which is just a little compact logic processor in a box. And we would do all the totalizing and the flow monitoring stuff. We connect the meters to the data concentrator, and then the data concentrator would speak to Ignition. We also use data concentrators for places where the machines weren't capable of speaking. So some of our packaging machines are old and proprietary. We'd again put a data concentrator out there, and we use some Ethernet remote I/O to hijack signals off of relays and off of sensors. So we take the information we need and actually pull it into a Rockwell data concentrator so we can get it into Ignition. We've also got a couple MQTT devices out there that'll speak directly to Ignition. To answer your question?
Yeah, for sure. What I did like, and I don't think people always think about it, is what you did with the what you're calling that data concentrator module, or box, where it sounded like you had something that's kind of a little bit off the shelf, where all of a sudden, if you wanted to pick up some points somewhere, you could deploy that panel, and you're going to be collecting data in a few hours rather than days or weeks to get that information, if at all. So that's a very clever way to solve that problem.
Yeah, it was very simple, especially with Ethernet I/O. You've got one, Cat6 that's dropped to, the machine, and you just put whatever devices you need at the machine. It all goes back to a central concentrator. Some of our plants have one concentrator, some have multiple concentrators, depending on the level of what we're monitoring at that given plant.
Right. So have you had to, do you take your investments then in IIoT, and then do you calculate your ROI based upon the amount of efficiency you've gained, or are you willing to share anything like that? Do you have any metrics to say, with this amount of investment, you've been able to create this amount of return?
For sure. I did a presentation at our managers meeting this year, and I showed the trend in OEE for each plant over the previous 12 months. And I had some hotshot in accounting. He did a corporate-wide zero-based analysis for me on historical rates versus T-max rates, and what a 1% increase in throughput annualized would be across every system in the company. And basically for us, if it was a microwave line, a 1% improvement annualized was $25,000 per line. So we had 12 microwave lines, and I just went right through every plant and showed, some were 40% improvement, some were 25% improvement. So I just broke it down and said, hey, if you're on a microwave line, if you do 1% improvement, it's $25,000 annualized. Multiply that by 6 in your plant. And oh, by the way, you did 12% improvement. And I didn't even do the math. I just said, you guys figure it out. I mean, it's millions and millions and millions and millions of dollars just in throughput increases. We're also utilizing it. Yeah, we're utilizing it to solve other problems. I mean, maximizing throughput and yield and making it repeatable in whatever system. The yield improvement is also, $25,000, $30,000 worth of improvement and a 1% yield increase.
And what I like about it is that it's kind of a gift that keeps on giving. That after you make that initial investment, the gains that you can get out of it are still there, but there's no more necessarily technology investments at that point.
I know we were $15 million better this year through 6 months than we were the previous year.
And we launched this the previous year. So that's an improvement after the big improvements.
Wow, that's some big numbers.
And ignition's cheap, so the ROI is basically infinite.
Yeah, that's $15 million is repeatable.
I mean, you invest $100,000 in software and you get a $15 million return in 6 months. I mean, it's allowed us to hire additional resources for the CI team and for my team. When we started this journey, we didn't have a single controls engineer in Sugar Creek. We had no continuous improvement activities at Sugar Creek. Now we've got dedicated continuous improvement resources. We've got 6 controls engineers that didn't exist before. And the more resources you throw at it, the more performance you get out of it, the more returns you get out of it. So it's like a snowball.
That's really amazing how you've been able to create the culture that continually now embraces it, is what I'm understanding. What I'm hearing is you're not fighting it, you're looking for the next improvement, you're looking for the next win.
It helps when you've got a single guy that owns your company, and his mantra is if the manager can't change the culture, then we can definitely change the manager.
Got it.
We had a question on talking about the improvements on the line. So when you talked about having even just a 1% improvements on the lines and that making a huge difference, the question is actually in terms of after you had the data collection, identifying the actual bottleneck of the line and what physically changed to kind of help the improvement. So the question is regarding, was the microwave itself the bottleneck of the line, or what was kind of the limiting factors that was affecting the overall production that was able to change?
So for the microwave itself, on that particular example, we know what the bottleneck equipment is on our lines based on what it's rated at. And for a microwave bacon line, the microwave itself is the bottleneck because you can only cook so much bacon given so many watts of microwave power. So some of the opportunities we had where we identified issues with the microwaves that were kind of flying under the radar. For instance, one of our microwaves did a lot of arcing, like a lot of arcing. So we actually went in and changed some suppression tunnels, changed some design to eliminate that problem. We had other microwaves where we weren't fully utilizing all the power. And you know, my favorite with the microwaves, and I'll let Craig talk about this, is we had different people running microwaves different ways.
When we first got to Dayton, I spoke to one of the managers, and they had these dashboards. They weren't utilizing them. He said, "I don't know why you guys are spending so much time here. I think what you're going to see is we're under control." So the first thing Dan did was develop some dashboards and some tools to show me the trends of microwave power output, belt speed versus slicer speed. So
I'll actually pull one up so you can see what he's talking about.
So I saw from one shift to the next on the line that we were concentrating on, as soon as second shift came in, they did an immediate 10% drop in slicer speed and belt speed. And I asked the manager at the time, I said, why would they drop the slicer speed and the belt speed at shift change? And he gave me a BS story of, well, they have to clean the microwave. It takes time for it to heat back up, so they're going slow. And I asked him how long that would take, and he said, well, we'll see. And I went back the next day, and they rolled like that all night long. So I asked the group the next day why they dropped the speed, and the manager on second shift and the supervisor on second shift gave me the same story. Well, you got to slow down because we do microwave cleaning. It takes time to build the heat back up. And then I extended the trend and said, yeah, but you did that all night. And then the only one that told the truth was the lead. He looked right at me and said, I like to roll like that all night long. So all I did was explain to him, and I asked him why. He said, do you see all the new employees we have on second shift? We can't maintain the rate that first shift does. And then I broke it down for him and said, by slowing down the amount that you did, you limited the number of packs per minute that a person has to put into the CFS machine from 16 to 50. Do you really think that they need that 1 pack per minute break? I said, do you think if you explained it to them that they would be able to maintain 16 packs per minute? And they turned it back up and they never looked back. Basically just by communicating what that rate should be. So in essence, we had 6 different lines, 2 different shifts, 12 different leads, running lines 12 different ways based on gut feel, eyesight. I know how to cook bacon better than you. So we just had to educate them.
Well, the funny thing is that the first shift guy was jacking with the speed throughout the entire shift. And we're like, why? It's like, well, you have to. Well, a microwave bacon line, pork bellies are not homogeneous. They're not rectangles. They're not solid. They're all different. So making decisions to run a whole line based on a little sample of what's coming out at any given time isn't a really good idea. So one of the things that Craig got him to do is, quit screwing with the line. Just lock it in if what the rate should be, and let's just see what happens. And they were able to run. So that's an easy increase.
So up to that point, you had no inclination that the lines are being, basically 12 different varieties of how the line was being run. You had no inclination of that?
There's no visibility to it.
Yeah. Even if it is visible, when you look at it, when you're looking at a dashboard at any given moment in time, it's just a data point. Until you start stringing together all those data points and seeing the trends of what's happening across one shift, two shifts, 12 different leads, that's where you get your true performance.
Got it.
I have to look at it historically.
Well, we're kind of getting to the end of our time together. One thing I always like to ask my guests is that something like, what are 2 or 3 takeaways that you could offer the audience today of something that they could take with them back to their organization to start moving forward down that journey of industrial Internet of Things?
I would say the biggest thing for me is just having the data and the dashboards and the data systems and on its own doesn't really do the job. I think what we're trying to do is build a performance system at the same time for the entire company. So really we're utilizing the data to drive every principle of our performance system so we can make all of this repeatable. So just having one on its own. And the other way too, it's tough to develop a performance system without having the data and the tools that you need to track the trends. So I think you really have to marry both of them together to show that type of success and make it repeatable.
And, like I said, start with the pain point. Go where the problem child is in your particular line and figure out how to break down the performance of that widget and develop a dashboard around it and get, the employees engaged. That's key. Data by itself doesn't do anything but tell you that you're not getting any better.
Yeah, we're really going to take what we've learned in the last 3 years developing these tools to track operations, and I'm going to steal it and I'm going to implement it in every aspect of the company. I mean, as far as showing people opportunity cost, material variance, showing people opportunity and quality and customer complaints and first pass quality, safety, tracking, trending. We're going to build tools in every other area of the company in a similar fashion.
Fantastic. Just out of curiosity, I think you touched on this a little bit. How much of your operations do you feel is connected?
From just the manufacturing equipment?
Yeah, as far as your manufacturing equipment, how much visibility do like how many pieces if you had 100 pieces of equipment, do you think 80 of them are connected in some fashion? I mean, do you have an idea, a metric of where you're at this point?
The guy sitting right next to me might have the answers to that. Hey, Caleb, what percentage of equipment you think we got connected? 90, 50 for production?
50. I just had 3 more things dropped on me to add.
So of our finished product lines, I would say 95% of our total lines, I would say, Caleb says 50, so probably 50.
There's a lot in Kansas.
Obviously we started with the pay point lines, and for instance, there's a lot more that goes into making bacon and slicing it and nuking it. We've also got to inject it and smoke it and chill it, press it, all that stuff. We've got probably 50% of that equipment online, but we know where the problems are because if we are stopping our pay point lines and it's because of curing, we code it as curing, and then we add equipment to that, then we add monitoring to that. But we started with our pay points.
Got it. So what I'm hearing is, just to sum up what I heard you guys is, start with a pain point, the data is important, but building that performance system around it to create scalability, and then employee engagement. Does that, those three things, what you think would be great takeaways?
Yeah, the key is the performance system. It's really not the data. If you build a performance system, it's gonna end up forcing you to get the data. You know, we kind of did it backwards. You know, what I'm used to in automotive is they build the performance system and then build the infrastructure to support the performance system. But we did the infrastructure first and built the performance system kind of concurrently.
Got it.
But if you've got effective problem solving, you know, those teams are going to need data, and they're going to tell you what data they need. So you can build it that way.
And we're really trying to drive the same tactics for every other area. And I've always been preaching, just get started with something. Don't wait until an entire system is built before you decide to spring it on us. Just start and build around it.
Okay. Those are great words of wisdom there. So unless there's anything else, I think we can wrap this up. I sure appreciate your time, and I hope that everybody on the call was able to get something out of it and was able to take it and make something valuable with it.
All right. Thanks, Matt.
Okay. Thank you so much.